In this video, we're going to take a look at common LCD displays. We're going to talk about how we hook them up to an Arduino, and we're going to actually do a build. We'll completely build an interface that will allow you to hook these guys together and make them play. So let's warm up the soldering iron and get started. Generally speaking, we have two choices when it comes to LCD panels that we can use in our various Arduino and other microcontroller projects. We have a smaller one, which is 16 columns by 2 rows, and a larger one, which is 20 by 4. Now, I recommend that you go with the 20 by 4. The difference in the price is only a few dollars, and the options that we have with this larger display are much greater. There's some interesting things that we can do. So this is the one that I recommend. Notice that both of these boards come configured so that you can attach a 16-pin header of your choice along one side here. These 16 pins are standard throughout the industry. We'll talk about them more later. This smaller display happened to come with a board already attached to the back that uses those 16 pins. This is an I2C board. Sometimes it's called I2C. It's an interface that allows you to control the LCD display with just a few connections from your microcontroller. We have ground. We have VCC, which is usually 5 volts. We have a data line and a clock line. And with those 4 connections right there, you can control everything you need to do with this display. I have a sample of that same piggyback board here. This could be plugged in or attached to this LCD like this. And if I soldered that in, then this would also communicate with your microcontroller using I2C. Including an I2C board to one of your LCD projects will add about $5 or $6 to the total cost, so that's a consideration. But if you're using a real tiny microcontroller, this is actually an Arduino clone that's only 1 inch square called a DigiSpark. It only has 6 I/O pins on it. So if I want to do a project that uses some sort of a display with this, I2C is my only logical option. A full-size Arduino with all of these available I/O pins opens the doors to 2 more possibilities that are not so limiting. The I2C option is a serial connection, which means that all of the data is sent 1 bit at a time to the interface board. Once all the data has been collected, it is then converted to parallel, and a parallel stream is then sent to the LCD panel. We could take advantage of the extra I/O pins that we have on our Arduino and send parallel data directly to the LCD panel. We have 2 choices. We can send that data as 8 bits, or, as is more oftenly done, we can send it as 2 sets of 4-bit nibbles. Another way to look at this is that one way or another we must send parallel data to our LCD panel. We can get that parallel data from an interface such as the I2C, or we can let our microcontroller do the parallel work for us. Let's take a look at how we could prepare this board so that we can hook it up directly to an Arduino and use a parallel interface. To build our own interface, we only need a few parts. We need a little PC board here, a little proto board that we can put things together on. We'll need a 16-pin male header and a 16-pin female header to go with it. I also want to use a little angled header here. This one has 8 pins and a little 10K ohm potentiometer that we use to adjust the contrast. Then, to link everything together, we'll use some ribbon cable. Let's start with a PC board. These are the boards that I prefer. They have copper strips running them along here, parallel to each other. And you can go in with a hobby knife and just simply cut the trace there to shorten the run so that you can put all kinds of components on this thing. You attach them usually on the back side here and solder them on the copper side there. Now, right off the bat, we have a simple problem to solve, and that is that we want to put our header on this board like this, so that it's going to connect to all of the parallel lines that we have that run along this board, and then that is going to eventually connect to our LCD panel here. And when we do that, you can see that the PC board is really too tall for this project. So what we want to do is cut this in half. Let me show you how easy it is to do that. The tool I like to use is this plastic cutter. It's available at most hardware stores. You can find it at Home Depot or Lowe's. Go into the section where they sell the acrylic panels that people put up instead of regular glass. This is the cutter that is used to cut those panels, and it's very inexpensive. I think you could get it for $5 or $6. It's real handy. I'll show you how it works. The cutter is a little deceiving at first. You might think that this edge out here is the cutting blade, but it's not. The cutting blade is down here inside this little hook. We actually do our cutting by pulling the blade towards us, and it'll peel off just a small layer of the material here on the back side of our circuit board. So to do that, I've already marked the center of this board here, and I will set up a straight edge. Now I'll take my cutter and lay it on here, and I just draw it back. Now you don't have to press hard on this at all. You just draw it back and you'll see a little layer of plastic material peeling off as we go along. Here's a closer view from another angle. I just pull the blade back along there, and you can see this material start curling up as I go. It leaves this little piece that comes off. We just do that over and over again. Now, periodically, you want to reverse the board because the end where you start isn't getting cut very well. So we'll set this up again. Also, we won't need this cutting edge, the straight edge rather, much longer once we get a good groove going. You can see how it just peels off in there. You don't have to apply pressure, just enough to make it work a little bit, like that. Now, so that I don't nick up the table here, I think I'll put a little piece of cardboard underneath here to catch the end of the blade as it comes off the board. Now that I have my groove in place, I can just pull it along here, and it mostly stays in place. Let's see, a little trouble with this one end. Well, that's because that's where we started, and it hasn't been cut here as much. So you just take several slices at it, over and over again. We'll turn it around again. And you'll see that you're developing pretty significant groove in the board here. After you've gone a ways on one side, we'll turn the board over and do the same thing on the other side, so that we end up with grooves back to back. I've flipped it over and marked the copper here. Now I'll be pulling it on this side. Now this has a different feel to it. The copper doesn't cut quite as easy as the backing does, and it feels kind of like you're pulling yourself over speed bumps. It's important that we keep going here until that clicking, that bumping goes away. we don't have to cut all the way through the board. We just need to get a good score on both sides. And I'll show you how we can easily break it. But I do want to get beyond the copper because I don't want any of the traces to try to peel off when I do the break. Okay, I think I'll do one more from the other direction. The place you start is never quite at the edge, so the very ends of these things always end up just a little bit shallow, and I would like to get those down as well. Okay, so now we're ready to pop this puppy in half. I've got a significant groove here on both sides, which I'm going to just now line up on a sharp edge here, like the edge of my workbench. And I'll just put it on there. I'm going to hold it down real tight, and I'm just going to push this down, and it should just break right off, like that. My cut turned out way better than I'm used to seeing when I do this project. And I think part of that might have to do with the fact that I wanted to be sure it went well for the video. But you may find that when you get done, you have a little bit of a rough edge there. So you just take a little piece of sandpaper, and we'll put the cut edge of the board down on the sandpaper and just kind of clean it up a little bit, sand it. Mine's pretty clean. Don't need to do this very much, but it's something that you might want to do with yours. Now that we've got our little PC board ready, it's time to get the soldering iron hot, because I'm going to put some headers on here and see how we can put these together right there like that. I would like to put the male header on the LCD panel. That way, if I want to do experiments, I could actually plug the edge of this thing in to a breadboard, for example, if I wanted to. So I've placed the 16-pin male header here on the back side of the board, and now I'm going to flip it over, and we'll solder it in here. Now, as it sits here, it's going to be at just a little bit of an angle, which is fine for now, because I'm only going to solder one connector. I'll go ahead and do this one, number 16. Pin 16 and pin 1 are both ground. I'll just put a little solder on that. Then I'll give it a look down here and see if I can't straighten it up, make it look a little straighter. I think I can make this job easier for myself. I just bring in a little breadboard here, and we've got number 16 soldered in already. I'm going to place this header down into the breadboard. That gives me a little something more to work with. Now I'm going to resolder pin 16 here. Kind of remelt it, and then turn my board just a little bit to get that straight edge there that I want. So it's a real good idea to make sure that you got everything lined up the way you want it to be. Your header's straight. It's down solid all the way against the underneath side of the circuit board. You can do that with only one pin soldered. Now, once you're satisfied, you can come down here and we'll just solder the rest of the pins. I think I'll go from this end backwards. You want to be sure that you heat up the lug first and then apply the solder. Then you won't get a cold solder connection. Okay, now I'll do pin 2. Pin 2 and pin 15 are both 5 volts. So we have our ground and our 5 volts like bookends at both ends of our board. There we go. Got a little bit of a solder glob right here. I saw it when I was putting it in. So we just kind of flick that guy off. get it out of there. Nice thing about the solder masks here, it doesn't really stick where it's not supposed to, so it comes off quite easily. And I kind of inspect my connections here, make sure that everything looks good and there's no soldering bridges, so I'm pretty happy with that. And we'll just gently remove the board from the breadboard, and there we've attached our header pins to the back of the LCD panel. I mentioned that pins 16 and 1 are both ground, and pin 15 and 2 are both 5 volt. You might wonder, why do we have two of the same thing on the board? Well, it turns out that the first 14 pins are the standard pins for the LCD display. They handle the parallel data plus 3 control lines, and there's also some pins there for the voltage and the ground. Over here, these last 2 pins, those provide the power and the ground for the LED backlight on our display, and they're separate so that you can wire them separate. Okay, now let's do the other half of this thing. We're going to take our female header, it's also 16 pins, and we're going to solder it on to the edge of our little printed circuit board. I don't want to try to put it on the very last edge here like this. Instead, I'm going to put it in one row. It just gives me something a little more firm. I just feel better, more comfortable with it in that location. Okay, I've got my helping hand set up here to hold the solder. I've got a hold of my board. My finger underneath is trying to hold the header in straight, and I'm just going to do like I did with the other one. I'm only going to solder one pin. Let's get that in there. Let the solder flow around it like that. Get that all set up. Put my soldering iron down, and now I have an opportunity here to inspect it and make sure that it's flat against the board. Everything's the way I want it. Now, we'll do just like I did before. I'll solder every one of these 16 connectors. We'll come back when that's done. Okay, I've got 2 more pins to solder here. When you're doing these, resist the temptation of just putting the point of your soldering iron down on the lug. You want to try to get the side of your iron on it. Let it warm up, then let the solder flow around there. And we'll do that one. And we'll do the same here on the last one. I ran into some trouble when I was doing this, and I saw a little bit of solder here come off my iron, and it seems to be in an area here where it looks like it could be causing some problems. And so I want to show you how I test my connections to make sure that there's no solder bridges. So I took my, let's get this out of here. I took my multimeter, and I've set the multimeter here to do this sounding. It allows me to test continuity. So if I take the 2 leads here on my meter and I put them together, you probably will hear a beep. And so when it comes time to test my connections here on the board, I'm just going to compare the neighbors and see there shouldn't be a connection between the 2. So I'll just walk through here, stepping through, kind of leapfrogging, and there shouldn't be a connection anywhere along the way. But there is. So I have a solder bridge right here, and we'll need to clean that up. The rest of the board seems to be pretty good. Let's see if we can go in there and clean that up a little bit right there. I'm going to try, first of all, to heat the solder and move the tip a little bit down this groove that separates it. If that solves the problem, we're in good shape. Otherwise, I'm going to get that cutter blade out again and drag it down that groove and see if I can get rid of that bridge. Oh, look, it's gone. We're okay. Yeah, that's supposed to do that because it's the same strip. So we're looking good. Now, if you don't have a multimeter that allows you to easily test continuity like I did there with that little beep, you can build a continuity tester yourself up very quickly. All you need is a resistor. Almost any value will do. This is a 1000 ohm resistor. an LED, and then some source of power. So I'm going to grab 5 volts and ground off of my Arduino over here and use it to light this LED. So if I take this line right here and I plug it in here, you'll see my little blue LED comes on. Well, to make this into a continuity tester, I'm going to remove this wire right here, and I'll put another one in its place so that now I have 2 ends. I can take my circuit board and I should be able to test the continuity the same way. When I'm touching 2 adjacent strips on my copper here, the LED doesn't come on. But if I was to find a short, which I can simulate by testing 2 holes on the same strip, the LED does come on. That LED over there tells me that I've got a circuit there. Sometimes you want one, sometimes you don't, but it's a real good idea to know which it is. We've got our 2 headers attached. Let's see how they come together. Just line these guys up and press them on. There we go. We're ready to start wiring this thing up. This schematic from the Arduino website shows us how we can hook up our LCD panel to an Arduino. Here on the right we see the LCD with the 16 pins. Pin 1 is at the top. Pin 16 is at the bottom. The top pin is pin 1 is ground, and the second pin right below it is our 5 volts coming from the Arduino. The third pin controls the contrast for the LCD display. You can see that it's attached to the potentiometer here on the other side of the schematic. The next 3 pins are control pins. Pin 4, RS, is our register select. That's how we tell the LCD if we're going to be sending a command to it, telling it where we want to print something, or sending it data, saying this is what we want to print. The next pin, pin 5, is the read-write pin. We have that one tied straight to ground. We're not going to be reading from the LCD. We're just going to be writing to it. And finally, the last pin here in this group is the enable pin. We send a pulse to this pin when we're ready for the LCD to print our character. These next 8 pins are the parallel data lines. They each represent 1 bit of a byte. Notice that bits 0, 1, 2, and 3, the least significant bits, have no connection to them at all. That's because we're only going to be using 4 bits of data. So when we want to send a character to the LCD, we'll actually send 2 different sets of data, 4 bits each. These last 2 pins, 15 and 16, show no connection in this schematic, but this is where we will apply the voltage that we need to light the backlight of our LCD. We'll actually tie these pins up to pins 1 and 2 on our interface board. Over here on the Arduino side, you'll see that our data pins hook up to digital pins 2, 3, 4, and 5. And the control pins are hooked up to digital pins 11 and 12. I'm going to make a change there. I'm going to hook up the control pins to digital pins 6 and 7. That'll give me 6 consecutive pins that I can work with, which will make it easy for a ribbon cable and with pins that'll plug right into the Arduino. So now we want to take these 4 data lines, 2 control lines, ground and 5 volts, bring them out of our header here and off to our Arduino. That's where our angled header comes in. We'll use this and our ribbon cable to connect our header here and the LCD display to our Arduino. We'll start by planning the ribbon cable. We're going to need a total of 8 lines. We'll have ground and 5 volts. Those will come in here. Then we'll need to add 4 data lines. They'll go in here. 1, 2, 3, 4. And then finally, the 2 control lines. Put one in here. And last of all, one there. So we use these 8 lines to form a ribbon cable. Let's just peel this apart right here. And this part will be done. Clearly, hooking these connectors onto our angle header there was a little bit tedious. We're going to make that job much easier in the future. We'll start with a little section of tape, cut it off here, and then I think we'll simply line this up on that edge there and tightly wrap this tape around this bundle of connectors. Kind of give the tape a little bit of a stretch as you do that. It makes it snug. It makes it so that it wants to pull itself together, make it nice, firm, and solid. Now that we've taped up the connectors, we can remove our header, set that down, and the plug sort of stays together. The tape is a little longer than we need here. So I'm going to just take this hobby knife, and I'm going to cut along here, making sure that I'm over the actual connectors. I don't want to cut the wire. We got to cut the corners, the edges here as well. I'll line that up there. Line that one up here. And then I will cut the other side here to line up with those best I can. Now, if all goes well, I should be able to cut the edge of it off right here so I can get a hold of this and peel the part that we don't need. Now, I've had people say, well, why don't you cut it before you wrap it on there? And the truth of the matter is, it's much easier to do it after it's wrapped. It's just a simple cut. Now we have that ready to go, and our angle piece here is ready to just plug that right in. We want the black side on that, and so let's solder this to our board. Notice that I created that plug wrapping those connectors with tape while they were attached to these angle headers before I soldered this on the board. That allowed me to get the tape around it easily. Makes it much easier to do. So the plan now is to attach this into the board here, and we want to make sure that the furthest pin on this side of the header, the angled header, matches up with pin 16 on the female header. So these right here now all just slide right over to there. When we solder this in, we're connecting pins right here directly to pins right there. And so I'll just go ahead and solder that now. As we've done before, I'm going to start by soldering only one wire, or one pin I should say. So we'll get that in there with my helping hands, the solder to flow around it. And then that allows me to examine the board here and make sure that I've got the header on straight. So you see the angles there a little bit. I think if I attach a end of a cable here just to one of those, it might give me something that would be easier to adjust it and move it to get it straight. So let's see how here. We'll loosen this solder up a little bit, get it straight. So look at it here. That looks pretty good. Everything else is down. Now I'll solder the other 5, and I think I'll come back after that and touch that first one up again. We'll do that and we'll come back. Well, I've got the angle header soldered on. Notice that I have left 3 rows of empty holes between the 2 headers. We'll be using those. So now we can just try this out. I'll put this on. The thing that I want to remember is that the black lead, which is going to be our ground, is going to go here on the outside edge. So it'll line up with ground over there. You'd have most of our connections already made. It's not perfect because we do need to connect to a few of these pins over at that end. We'll do that with some jumpers, and underneath we'll be cutting some of those traces so that these last few pins here don't connect up to the pins that we're not using over here. You should recall that 2 of the lines that will be running over to our Arduino are control lines, and they're coming from over here on our header. They're not in line with the pins that we have here. So what we'll need to do is to flip this board over and cut the traces between these 2 pins here and the corresponding female header pins there where we don't want a connection. Let's flip it over, and you'll see here that we just take our hobby knife and cut those 2 traces. It's the inside 2, and do a few cuts in there. Then we want to make sure that we've got no connection between them. And to test that, we'll use our continuity tester. As we've done before, I'll take my leads here. You should hear that. We'll put 1 pin on one side of the cut, 1 pin on the other side of the cut, and we don't hear the beep. We'll move to the second strip. There is no beep. Now when we move to the third, we do want a connection, so we should hear it. And we do. So we've successfully removed the path between these last 2 angle headers with those 2 pins that are located on the female header. Now I'm going to make the first of one of our jumper wires. So I've taken a piece of hookup wire here, and with my hobby knife I'm going to just cut through the insulation. I'm rolling it with my finger here so that I can cut all the way around this piece. I think there's one part that I still haven't gotten because it hasn't rolled over. If you bend it slightly, you should be able to see where your cut is. Now I take my fingernail, put it in there, and I should be able to pull this guy right off. I'm going to show you a trick. I'm not going to throw this little piece away. It's going to come in handy here in a minute. So now I have the wire bare here, and I will cut this off. And that's the piece we want to use. We won't lose it. So what we're going to do is we're going to run a jumper from our second pin right here over to the 6th pin on this piece right there. And now this piece over here that I cut off there, this is not necessary, but it is kind of attractive. We're going to lay this down here as if it was wire. And remember, we want to go to pin 6. I'm going to go 1, 2, 3, 4, 5, 6. I'm going to come down here and just cut this off right there. And like I say, this isn't necessary, but it sure makes things look good. We'll just put this back on our wire. Let's stick it right back on there. Then we'll take that other end, bend it down. I'll try to make these bent pieces nice and straight, as straight as I can get them here. I like to make things look good. People are going to look at the work you do, and you want to show it off. There's an opportunity to make it look really nice. So we'll get those all straightened out. Nice and pretty. Now I had to catch myself here. I got this all ready to go, and I was getting prepared to put it in here, back here, but that would have been a serious mistake because I've already cut the lead between here and there. So I need to put it on the other side of the header here. So it'll go right in here like this. Press it down, and so this will form a jumper between pin 6 there and the second pin on our header. So all I have to do is flip it over, and we'll solder it together. I'll do that, and we'll be right back. Okay, I've got the first pin side of that jumper soldered. Let's finish it up by soldering the second one. Warm it up first, then we apply our solder. Let it flow. There we go. Now, where's my cutters? We can clip off those extra leads. And our first jumper is on the board. Well, I've added a second jumper. This one I did the same as the first. This one runs from the last pin over here on our angle header over to pin 4 on the female header. So it's all in there, it's all soldered, and we're ready to move to the next step. Now we want to install our potentiometer to adjust the contrast. I've just set this in here so that I can show you where it's going to go. One leg of our potentiometer, the far leg here, needs to pick up 5 volts. We're going to get it along this strip right here, which is coming from pin 2 on our female header. The contrast adjustment is at pin 3, so the center connector of our potentiometer is going there. The third leg of our potentiometer is in line with the 4th pin of the header, which is also where our jumper is here. We don't want a connection between that jumper and this potentiometer. So I'm going to take this out, and we need to cut the trace right in here. And we'll check the continuity. Very good. No connection. I've soldered the potentiometer back on the board, so that's ready to go. Now, if it seems odd to you that we're putting this piece on the copper side of the board when everything else is over on this side of the board, you need to consider where this is going. When we plug this in to our LCD, we need to be able to get at that potentiometer. That's why it has to be on the opposite side of the board from all the other parts. Right here, you'll see the 3 pins of our potentiometer. This first pin right here runs down this trace and connects to the second hole of our female header. That's 5 volts. The center one comes down here, connects to the third hole on our female header for the contrast. We need to take this third pin and connect it to ground, which is clear over here, the first one. So to do that, I've added a jumper back here that will take this pin, bring it into the column where pin 1 is there. Remember, we cut this jumper underneath here, or we cut the trace rather underneath here, so there is no path through here. So that takes care of hooking up our potentiometer. Now we need 2 more jumpers, because we need to take 5 volts from here and bring it over to there, and the ground from here over to there. This black wire here jumps the 2 end pins. That's our ground. The red wire, pins 1 and 15, that's our 5 volts. Now we need 1 more jumper. Remember, we have a read-write pin that we tie to ground because we're only going to write, we're never going to read. So we need to find pin 5, 1, 2, 3, 4, 5, which is right here, and run a jumper from there also to ground. Then that should finish our project. Well, before we hook this up to our LCD panel, let's check the continuity here. I've put an angle header across here so that I can make it easy for me to bring a probe in and test it. So we'll start right here. We have, this is pin 1. It's supposed to be ground, and so we'll check it right here. I guess that's pin 16, that's not pin 1, but it's still supposed to be ground. And way over here, this is pin 1, and that should give us a bell there as well. And it does. We should not be getting a reading with this one, our 5 volts, and we don't. So we know then that there's no short between the two. Those are not shorted out. That's good. Let's go from this pin here to 5 volts there. That works. And we should get the same reading over here. And we do. Now, this third one should go to the third one here. And the fourth one should go to the fourth one here. And the fifth one should go to the fifth one here. And the sixth one to the sixth one. That's fine. Now, the seventh one should not go to the seventh one here. It goes clear over here to, I believe it's pin 6. So let's check it over here. These pins want to fall right off of there, but so we go 1, 2, 3, 4, 5, 6, and we've got a good connection there. And then the last one, it goes over to pin number 3, I think it is. It's 4, yeah. It's supposed to be 4. Okay. That takes care of all of those. So those are ready to go. I'll remove the board from the helping hands here. And let's take these spare headers out that came in handy when we wanted to use test probe. So this is ready to be hooked up. Let's start with our ribbon cable. When I created the ribbon cable, I planned it so that this edge wire, the edge lead here, would be black, because I know that this pin right here at the far end of our board is ground. And by putting it that way, I know that when I plug it in, I put the black one in on the outside, and then all the others will be right where they need to go. So this is ready. We can now attach that to our board. So there we go. We've got a LCD display with a ribbon cable attached to it. Let's get the Arduino out and hook that part up. I've got the black and the white wire coming in here. Those are ground and 5 volts. So black is ground and white is 5 volts. And then these remaining 6 wires are set up so that they're going to go right in order. We start over here with Arduino's digital pin 2, and we just go 2, 3, 4, 5, 6, and 7, and they'll line right up right there. I can take a little tape now and wrap it around those to create a plug on that side, and I can do the same over here. But before I do that, let's plug some power in and see what happens. Currently, this Arduino is programmed with my Morse code decoder software. So when we plug it in, we should see that screen come up over here. So let's plug it in. And look at there. It works. Now, if you don't see letters come on yours, don't forget to try turning the contrast knob that's on the other side. What remains to be done here is to tape these right in here, finish making those plugs, and we have created a nice interface. We've taken an LCD display. It's all ready to go. Nice and tidy. Everything's put together, and we have a pretty multicolored ribbon cable hooking it up. Where do all these parts come from? Almost everything you see here has come right off of eBay. You can find the ribbon cables there. You can find the various headers there. I've also noticed that our friends at Adafruit, they're also selling these headers, so you can get them there. I even found the printed circuit boards on eBay. Do a little searching, find them online, order them, and then when your parts arrive, you can build a nice interface for your LCD display also. And hey, don't forget to subscribe, like, and share.